Hi guys, let's look at a new chapter. This chapter is called triangles. There was some part of this chapter in class 8 as well. This chapter basically involves using congruency. So extremely important chapter from the fact that this concept will be applied in many more chapters in your textbook. So let's start looking at this. To prove congruency, there are 5 basic methods. The first one is called SSS test. So this SSS test basically is side, side, side. Now, if in two triangles all corresponding sides are equal, which means AB is equal to PQ, BC is equal to QR, and AC is equal to PR, then by SSS test of congruency, these two triangles are congruent. And we will write this as triangle ABC is congruent to triangle PQR. Now, A corresponds to P, B corresponds to Q, and C corresponds to R, which means angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. That's why writing it in correspondence is extremely important. Let's look at the second test. The second test that we do here is basically a side angle side test, in short form written as SAS test. So side angle side. Notice that the angle is between two sides. So similarly, the angle has to be between the two sides. In the name, it's between the two sides. Even in the diagram, it'll have to be between the two sides. So this is AB is equal to PQ. So AB is equal to PQ. Angle B is equal to angle Q, and BC is equal to QR. So this is side, this is angle, this is side. So we will write this as triangle ABC is congruent to, this is the sign for congruency, is congruent to triangle PQR. Notice that angle A will be equal to angle P because these are in correspondence. B will be equal to Q, which is already given, and C will be equal to R. So this is the correspondence. Let's look at the third test. The third test is angle side angle. So angle side angle. Notice this time that the side is between the two angles. So even in the diagram you would notice that this is the included side between the two angles. Like in the previous one, it was the included angle between two sides. This is included side between two angles. So this is the included side. So here angle E and angle N are equal, angle F and angle O are equal, and EF is equal to NO. So we will write this as triangle DEF is congruent to triangle D corresponds to L, E corresponds to N, and F corresponds to O. This is the correct way of writing. Now in case I write this as triangle DEF is congruent to triangle NOL, this will be completely incorrect because angle D and angle N are not equal. What is equal is angle E and angle N. So if E is in the middle here, N will have to be in the middle here. If F and O are equal, which is given, F is in the end, O will have to be in the end. Let's look at test number 4, which is angle side. Now notice this is angle, and then side. So this is angle followed by another angle followed by a side. Similarly, angle followed by an angle followed by a side. One more way of looking at it is, the way I try and look at it is, I always mark symbols on the diagram, rough diagram that I do, and I notice which side is equal. So let's look at this visually. In diagram 1, my side which is opposite single line is the one that I'm looking at. In this second diagram also, the line which is the side which is opposite the single line is equal. Now in case in this question this side was given, then these two triangles will not be congruent using this method. Maybe another method we can try, but this method they will not be congruent. So they will have to be the corresponding side. So now this is triangle PTD is congruent to triangle P corresponds to I, T corresponds to K, and D corresponds to C. That's why correspondence is extremely important in your exam. In case the correspondence is not correct, you do not get full marks. So that's the fourth test, and this is my fifth test, which is known as a right angle, hypotenuse, and side test. So a right angle are equal, hypotenuse and hypotenuse are equal, and one side is equal. So this is by right angle hypotenuse test, in the short form RHS test. So we will write this as triangle KRO is congruent to triangle ATD. Now in these examples that I gave, I made the diagrams exactly in the way they are corresponding, so it was easier to look at. But when we do real questions, we may not find diagrams in exactly the same order. So we will have to look at them. I wanted to remind you, this test can also be converted into an ASA test, because if two sides of two angles of a triangle are equal to two angles of another triangle, then the third angle obviously is equal. Let's take an example. Let's say this is 45 degree. Let's say this is 70 degree. So what is the total sum of three angles? Three angles sum will always be 180. So this is 115, which means this will have to be 65. 180 minus 115. Let me check. 100, 170, 180. Perfect. Similarly, the question says 45 is equal to 45, 70 is equal to 70. We have not been given this angle, but we calculated. Similarly, we will calculate that this angle is 65 degree. Now, in case I make this angle a 65 degree, now let's try and prove the congruence using another method. So let's look at this. Angle P will be equal to angle I. Why? We just calculated it's 65 degree. We know that PD and IC are equal. This is given, and we know angle D is equal to angle C is equal to 70 degree, which is given. Now what does this turn into? Now this turns into angle side angle. The side is between the two. This is the included side between two angles. So that's why this also now turns into angle side angle. So basically AAS is a type of angle side angle where the third angle is not given, but it will be equal. So 5 tests of congruency: SSS, SAS, ASA, AAS, and RHS. So these are the only 5 methods. Any other method, there is no test called SAA, there is no test called ASS, there is no test called AAA. These tests do not exist, so we should be careful on how we are looking at the questions. Let's try and solve some questions. Maybe our life will become easier when we solve some questions. So let's look at some questions. I am on exercise 9A and I am on question 1, part A. It says, which of the following pair of triangles are congruent? In each case, state the condition of congruency. So I am in question 1, part A. I have already drawn a rough diagram. It's my habit to draw a rough diagram for all kinds of questions. It says AB is equal to DE, which I have already marked. It says BC is equal to EF, already marked. And the third point is angle B and angle E are equal. Now when I look at the 5 tests, so I always write them in the side: SSS, SAS, ASA, AAS, and RHS. So RHS we should look at only when it's a right angle. There is no information given. I notice this side is equal, corresponding side is equal, and included angle is equal. So this is basically a side angle side test. That's why these two triangles are congruent. So triangle ABC is congruent to triangle DEF. Again, please note the correspondence of sides and angles. Let's look at question number 1, part C. In triangle ABC and QRP, AB is equal to QR, which means AB is given equal to QR. Angle B is equal to angle R, which is already marked. Angle B and angle R are equal, and angle C and angle P are equal. So this time I have side angle angle, there is no such test. Then let me read it the other way, angle, angle, side. Let's check the side which is opposite the double line is what we are looking at. In this also, the side which is opposite the double line which we are looking at. Therefore, by AAS test, angle, angle, side test, triangle ABC is congruent to triangle QRP. Next question, question number 1, part D. It says triangle ABC and PQR, AB is equal to PQ. So AB is given equal to PQ. AC is given equal to PR, so AC is given equal to PR, and BC and QR are given equal. So in this, all three sides are equal. Therefore, by SSS test, triangle ABC is congruent to triangle PQR. Right? Simple, isn't it? Let's look at some more questions. It will become even more clear. Let's look at question number 2. It says the given figure shows a circle with center O. So this is the center O. P is the midpoint of the chord AB. So AP and PB are equal. We need to prove that OP is perpendicular to AB. So we need to prove that this is perpendicular. So let's look at this. Do you see any triangles here? No, but can we create some triangles? Yes, we can. Maybe I can join OA and I can join OB. Joining this will help me create two triangles, and I will be able, if I can prove them congruent, then maybe I will be able to look at it from further. So let's look at this. The first step, number 1, join OA and OB. Now number 2, always a good habit to write your numbers, because we will be referring to these numbers later in the question. We may need to. Now OA and OB, is there any relationship between them? Yes, I know OA and OB will be equal because these are the radii of the same circle. So OA is equal to OB is equal to radius of circle. So since they are the radius of the circle, they are equal. So let's look at which two triangles do I want to prove congruent. So in triangle AOP and triangle BOP, I always draw a rough diagram of the two triangles that I want to prove. This helps me in understanding which triangle I am looking at. For me, it helps me understand the question better. So this is not 90, wrong mark. This side and this side are given equal. OP and OP are equal because they are common side. And I just proved that OA and OB are equal. Oh, I think I've already proved it. This is SSS test. But now let's write this down. So we've got number 3. OA is equal to OB. This is from number 2. Number 4 would be AP is equal to BP. This is given. Writing reason is important for your examination marks perspective. If there are marks for giving reasons. AP is equal to PB is given in the question, and OP is equal to OP, which is common arm. So therefore, by SSS test of congruency, these two triangles are congruent. Triangle AOP will be congruent to triangle BOP. Notice A corresponds to B, P corresponds to P, and O corresponds to O. Done. So let's look at this now. So this is my part 6. So now that these two triangles are congruent, therefore angle OPA is equal to angle OPB. Right? Did I share this with you earlier? In case two triangles are congruent, which means if these two triangles are congruent, then all corresponding sides are equal. Corresponding sides are equal. And corresponding angles are also equal. We've done this earlier as well, so maybe I did not share it in the beginning of the video, but this angle will be equal to this angle will be equal to this angle, and this angle will be equal to this angle. Right. So in a corresponding, in congruent triangles, corresponding parts of congruent triangles are equal. So this is my next part, which is number 7. Why is this? This is corresponding parts of congruent triangles are congruent. Now you already know that this is written in short form as CPCTC, and this is an accepted short form. So from now on we will not be writing this full sentence. I will just be referring to it as CPCTC. So that angle OPA and angle OPB are equal, which means this angle and this angle are equal. So let angle OPA is equal to angle OPB is equal to X. Now angle OPA plus angle OPB, it will be equal to 180 degree. Why? Because this is a linear pair. So 2x x plus x is equal to 180 degree. 2x is equal to 180 degree, which means x is equal to 90 degree. Therefore angle OPA is equal to angle OPB is equal to 90 degree. Is that what they wanted me to prove? Yes. Therefore OP is perpendicular to AB. Hence proof. Always a good habit to highlight your answer. In this question there was only one part, so I have highlighted the final one. Perfect. Let's look at the next question. The next question that we do is question number 4. Let's look at question number 4. Question number 4 says, in a triangle ABC, D is the midpoint of BC. So D is the midpoint of BC, which means BD and DC are equal. Next, AD is produced up to E. So I have extended AD up to E, so that DE and AD are equal. Now DE and AD are also equal. So DE and AD are equal and BD and DC are equal. Prove that triangle ABD and ECD are congruent. So let's look at these two triangles, ABD and DEC. So let's look at this. This angle and this angle will be equal because these are vertically opposite angles. This side and this side is given equal. This side and this side is already given equal. So I think we've already done this question by, like I said, I always try and draw a rough diagram separately to help me understand the question better. So this is, for me, this is DCE. This angle and this angle are equal, vertically opposite. AD and DE are equal, this is given, and BD and DC are equal. Let's write this down and that'll finish this question. So now number 1, this number I've already taken. So number 4, AD is equal to DE, given. Next, angle D is equal to angle D. Why? Vertically opposite angles are equal. Right now I've written angle D is equal to angle D. This is not the best way of writing. It's always a good habit to write your angles in 3 letters. So this is angle ADB is equal to angle EDC. Next, this is number 5, not 2, and next one is number 6, which is BD is equal to CD, given. So we have got 3 points that we needed to prove my congruency. Let's write this down. Therefore, by SAS test of congruency, triangle ADB is congruent to triangle EDC. I looked at corresponding sides. AD is this 2 line and I am reaching this angle, so ED, that's how I wrote AD and ED, and then the remaining one. Perfect. Is there a second part? Yes, there is a second part. I need to prove that AB is equal to EC. So now let me give this a number. This is number 7. This is what I want, what they wanted me to prove in the question. So here I will highlight this saying this part is done. Let's look at part 2, which I have to do AB and EC. Now number 8, since these two triangles are congruent, which means corresponding parts will be equal. AB, which is first letter and the third letter, and EC. Perfect. So this is congruent as per these are corresponding sides. So AB is equal to EC, CP, CT, C. So this is the second part that I've proven. Done. Let's look at part 3. AB is parallel to EC. So I need to prove that this line and this line are parallel. Now let's revise certain properties of parallel lines. In parallel lines, so I'll write this here. In parallel lines, if you have a transversal is the line which cuts a pair of parallel lines, then corresponding angles are equal. Anything else you remember? Yes, alternate angles are equal. And anything else? Yes, the third point is sum of co-interior angle is 180 degree. So these are the three properties which I remember. I just revise it quickly. So let's see if I can prove any of these. So I notice because these two triangles are congruent, this angle and this angle are equal, and this angle and this angle are equal. We've already proven that these two triangles are congruent. So does it help me prove anything? I notice that angle B and angle C, these are alternate angles. So if I look at, let me just write this for you. If AB is parallel to CE and BC is the transversal. So this is what I'm looking at. I always prefer to highlight what line I'm looking at. So I'm looking at this line, and this is the transversal that I'm looking at. So then this angle and this angle become, yes, they become alternate angles. So transversal, angle B and angle C are alternate angles. Right. Again, a good habit to write them in three lines, three letter for the angle, so are alternate angles. So number 9, angle ABD is equal to angle ECD. Why? Again, CPCTC, and since angle ABD and angle ECD are alternate angles, therefore AB is parallel to CE. That's the third part that they wanted me to prove. Done. Let's look at the next question. The next question that we do is question number 6. The perpendicular bisectors of the sides of a triangle meet at I. So perpendicular bisector, which means let's give them some names. This is D, this is E, this is F. So BD and DC are equal, AF and BF are equal, AE and EC are equal, and angle DEF are all 90 degrees. These are perpendicular bisectors. So I need to prove that IA is equal to IB is equal to IC. Let's see if I can prove any triangles congruent. See many triangles here. Let me see where does IA come. So IA comes in this, IB is here, and IC is here. Are they part of any two triangles? Yes, if I look at this triangle, I am highlighting this triangle BFI and AFI. Let's look at these two triangles. AI and BI are a part of this. So let me see if I can prove them equal. Let's try. So this is, I draw a rough diagram for my reference. This is what I have drawn is I here, A here, F here. This is I, B and F. Angle F is 90 degree given, BF and AF are given equal, and FI and FI are equal. Why? Because this is common side. So now I have side, angle, side. Perfect. Let's start writing this answer. We've already just the rough diagram and putting whatever we knew in the question has helped me solve it already. So let's write in triangle BFI and triangle AFI. What all do we know? Let's start writing. Number 1, side, which is BF, is equal to AF. Why? This is given. Number 2, the angle, which is angle BFI, is equal to angle AFI, is equal to 90 degree. This is also given. Next part is Fi is equal to Fi. Why? Common arm. Notice that we need to definitely write the reason of what we are taking as, or what reason for why we are taking this to be equal. So use by SAS test. This is side, then angle, and then side. The angle is between these two sides. Triangle BFI is congruent to triangle AFI. This is my number 4. Number 5 would be, therefore, BI is equal to AI. CPCTC. So I have proven BI and AI are equal, which is I have proven this part of my question. Now I need to prove that either of them is equal to IC. Now let's see if BI and IC, there is something that I can look at. Yes, if I look at BI and IC, maybe I can look at these two triangles BID and CID. So now in triangle BID and triangle CID, again I would draw a rough diagram for my reference. This is I, D, B, and C. This is 90 degree, this is 90 degree. BD and CD are equal, and ID and ID are equal because this is common arm. Let's start writing. Number 6, BD is equal to CD, given. Next, angle BDI is equal to angle CDI is equal to 90 degree. This is also given. And then the last part, DI is equal to DI, common arm. So then again the angle is included between the two sides. Therefore by SAS test, triangle BDI is congruent to triangle CDI. So this is my number 9, and number 10 will be BI is equal to CI. Why? CPCTC. So I've got BI is equal to CI and I've got BI is equal to AI. Therefore, by combining number 5 and 10, I get BI is equal to AI is equal to CI. This is what they wanted me to prove. So hence proved. Done. Let's look at the next question. The next question that we do is question number 8. So if AP bisects angle BSC, so this is angle BSC and AP is bisecting, which means angle BAP and PSC are equal, and M is any point on P, prove that the perpendicular drawn from M to AB and M to AC are equal. So to prove that MN and MQ are equal, so let's look at these two triangles and see if they will help me prove anything. The triangle that I'm looking at are AN, this is N and this is M. This is 90 degree, and the other triangle is AQM. A rough diagram for me helps me understand. As per the question, NAM and MAQ are equal, and angle Q and angle N are equal because they are 90 degree, and AM and AM are equal. Why? Because this is common arm. So let's see if I can get something. Two angles and one side are equal. Let's see which side is equal. The side opposite 90 degree. Here also the side opposite 90 degree. Perfect. So I've got my answer already. This is angle side. Let's start writing. So in triangle ANM and triangle AQM. Number 1, angle NAM is equal to angle MAQ. Why? This is given because AP bisects, since AP bisects angle BAC. So this is my reason for NAM and MEQ being equal. Number 2, so angle AQM is equal to angle ANM is equal to 90 degree. This is given in the question. And number 3, AM is equal to AM, which is my common arm. Perfect. Therefore, by AAS test of congruency, triangle ANM will be congruent to triangle A corresponds to A, N 90 corresponds to Q, and M is M. So this is my number 4. So that finishes my question. Therefore, MN is equal to MQ. This is CPCTC. Done. Let's look at the next question, question number 9. Let's look at question number 9. Question 9 says, from the following diagram in which ABCD is a parallelogram. So ABCD is given as a parallelogram. Remember the properties of a parallelogram. Opposite sides are equal and parallel. So CD and AB are equal and they are parallel. Similarly, AD and CE are equal and they are parallel. Perfect. So let's look at the question. It says ABCD is a parallelogram. ABL is a line segment. So this is a straight line. Line segment, and E is the midpoint of BC. So E is the midpoint of BC, which means BE and CE are equal. We need to prove that triangle DCE, which is this triangle, and triangle BEL or LBE are congruent. So let's try and figure it out. So what else do we know? I know this angle and this angle will be equal because this is vertically opposite angle. I have ones, nothing else. Anything else that I can look at? Let's see. So let's draw the rough diagram and see if we can get something equal. So this is D, C and E. This is E, B and L. So this angle and this angle will be equal. They are vertically opposite. Anything else that I can prove as equal? Yes, CE and BE are given equal because these are, it's already given. E is the midpoint. So I need to get one more thing. Maybe parallel lines would help. So let's look at the parallel line as DC and AL, and DL is my transversal. So what do these two angles become now? Yes, they become alternate angles. So these two angles will be equal. Now let's write this in the question. Angle D and angle L will be equal because these are alternate angles. So now that we've got this, I think we've already have the answer. This would be angle, side. Let's check. This side is opposite two lines. This side is also opposite two lines. Perfect. Number 4. Angle BEC is equal to angle LEB. Vertically opposite angles are equal. So that's the reason for this angle to be equal. Next is the second angle, which is angle BLE is equal to angle CDE. Why? Because these are alternate angles are equal. Done. And the last part, DE is equal to CE. Why is that? This is given. Therefore, by AAS test of congruency, triangle DCE is congruent to D corresponds to L, so L, C corresponds to B and E corresponds to E. So triangle DC is congruent to triangle LBE. This is the first thing that they wanted me to prove. Done. This is my number 7. What's the second part? AB is equal to BL. So let's say DC will be equal to LB. Why? CP, CTC. But I already know that DC and AB are equal. But AB is equal to DC. Why? Opposite sides of a parallelogram are equal. So these two sides are equal, and that should get me the answer. So that will be number 10, combining 8 and 9. If I combine 8 and 9, I get AB is equal to CD is equal to LB. This means AB is equal to LB. That's what they wanted me to prove. That will be number 11 for me. Last part, I need to prove that AL is equal to 2DC. So AL is equal to AB plus BL. Yes, AL is equal to AB plus BL, and AL would be equal to DC because AB is equal to DC from 9, and BL is equal to AB equal to DC plus DC. Why? Since AB is equal to CD from 9 and AB is equal to BL from 11. So BL and AB are equal and AB and CD are equal. Therefore, AL is equal to 2DC. That's the last part that they wanted me to prove. That's also done. That finishes this video for me. Some homework questions for you. Question number 1, part E. Question number 3. Question number 5. Question number 7. Take care and be safe. Bye-bye.